Hello dear students, welcome back to the NEET Physics Crash Course 2026. In the earlier three lectures, we have covered the trigonometry, algebra, coordinate geometry and slope of the basic maths portion of the physics. In this lecture, that is lecture 4, we will deal with differentiation, which is a very important topic. In all the sections of physics, this differentiation plays a very crucial role, isn't it? So keep patience and step by step, we will learn what is differentiation, what is its requirement. And first of all, before understanding differentiation, let us understand clearly what is slope and what is the real life applications of slope. So, for example, uh, the the very common example of slope is in civil engineering. Suppose you visit a mountain or hilly areas where road is having some steepness. So the steepness of this road is given by grades. The steepness of this roads is given by grade. Suppose I am writing here grade of this road. Grade of this road is equal to 10%. Now 10% means this is 10 by 100. So what does it mean 10 by 100? It means that for every 100 meter you cover along horizontal direction, you will get rise by 10 meter. For example, this is road. As you see, this is road. Suppose this is point A and this is point B, and this distance is 100 meter. Now when you move from point A to point B along this road, you get shifted by 100 meter along horizontal direction. It means that you are shifted by 10 meter along vertical direction, isn't it? So for every 100 meter along horizontal direction, you will get rise by 10 meter along vertical direction. So this is the meaning of grade. So what is this actually? And suppose you have covered 200 meter, then along horizontal direction, then you will get rise by 20 meter. So what is this? This is known as, what is 10 here? This is 10. This is 10 meter. So this 10 meter is nothing but rise, and this 100 meter is nothing but run. Are you getting? So what is grade? Grade is given by rise by run. And as we have seen in the lecture number 3, that slope is also given by rise by run. So this slope or this grade is nothing. So slope is equal to grade, and its formula is given by rise by run. Are you getting? Now suppose if I take this value as angle theta, so in triangle AB, let us suppose this point is C. So in triangle ABC, tan theta is given by this BC by AC. BC by AC, that is opposite side by adjacent side. And what is BC? Here BC is 10 and this is 100. And this is nothing but rise by run. So what are the informations we are getting here? Slope, the real life application of slope can be seen in finding the grade of the road, isn't it? And this grade of the road plays a very important role while designing any road, any flyover and something like that. So what is slope? So the very important point is slope is definitely rise by run, and this is given by tan theta. So this is very important, dear students. Slope is rise by run and this is given by tan theta. And one key point of this slide is note point: as long as theta remains same, slope will not change. It means that slope is also same. That is because slope is equal to tan theta. Second important point, as theta increases, so tan theta increases because tan theta increases with increase in theta, and implies that slope increases. Are you getting? As theta decreases, slope decreases, and as theta is constant, then slope will be constant. isn't it? And as theta is equal to 0 degree, it means that tan theta is equal to 0. It means that slope is equal to 0. Are you getting? So let us suppose this is example, this is one case 1, this is case 2, decreasing theta, theta is equal to constant, case 3, and theta is equal to 0, that is case number 4. Now I am taking examples of these all cases. So suppose, let us take example number 1, है ना, where theta is increases. So one of the graphs representing increasing theta is, so this is the graph. Are you getting? This is the graph where theta increases. Now how can we take theta? As we have learned in lecture 3, that first of all what we do, we draw a line. Suppose I wish to measure angle theta at this point and name it this point as A. Let us suppose this point is A. So the very first step is I draw a line parallel to x-axis from this point. So let us draw with a ruler. So I am going to draw a line here. So this line is parallel to x-axis, and for taking theta, we have to draw a tangent. And as you know, what is tangent? Tangent is any line that passes through single point to the curve. Suppose I am drawing tangent here at this point A, isn't it? So this is tangent, dear students. This is tangent. This is tangent. So here this angle is theta. Actually, this angle is theta. This angle is theta. Let us suppose that is theta A, isn't it? Now let us take some another point B. Now let us suppose this is point B. This is point B. So here again the same procedure. What we do, so first of all we draw a line parallel to x-axis. So we are drawing a line parallel to x-axis. And the second step is take tangent that passes through this point. And angle between this tangent. So this is theta B. So this angle is theta B. Now as we can see that theta B is greater than theta A. It means that tan theta B is greater than tan theta A. It means that slope at B is greater than slope at A. So this is the graph of increasing slope, and this is known as inclination. This is case of inclination, isn't it? This is case of inclination. Now the second is, let us suppose the second is, what was the second case? That is decreasing slope. Theta decreases. So its graph will be like, so let us suppose this is y-axis, this is x-axis, and the graph like this. Let us suppose 2 points. We are taking 2 points. This is point A and this is point B, where we need to find the slope. This is point B, point A, point B. Again same procedure. So I am drawing it. So I am drawing it freehand. So this is line parallel to this x-axis, and if you observe, the tangent goes like this. This is tangent, isn't it? So this angle is theta A, and here this angle is theta B. So what you observe here, that theta A is less than theta B. It means that as slope decreases, as angle decreases, so its tan theta A is less than tan theta B, and slope at A is less than slope at B. So this is the example of decreasing slope, that is the curve is having declination. the curve is having declination, isn't it? Now the third is constant slope. The third one is constant slope, that is theta is equal to constant. Now when theta is equal to constant, it means that the curve is a straight line, because anywhere you will take theta, this theta will remain same. So this is the example of, that is a straight line is an example of constant slope. And the last one is theta is equal to 0, that is the slope will given by tan 0. So tan theta is equal to 0 is equal to slope. So this is the line, this is x-axis, y-axis, and any line parallel to this x-axis will have 0 slope. Any line parallel to x-axis will have slope 0, because when you find theta here, you will get the value of theta equal to 0. So these are the different cases, dear friends, where we can directly see that if you are able to observe the value of theta, then slope can be easily found out by using the formula, that is tan theta. Now for finding tan theta, as we all know that tan theta is given by perpendicular by base, that is the length of delta y, I mean vertical direction, length of vertical direction by length of horizontal direction. What I am saying, let us, I am going to explain it very clearly. So so the conclusion of the previous slide was slope is given by tan theta. Now there are two methods, or we can say there are two ways which we can I mean in which we define the slope. That is, the first one is average slope and the second is instantaneous slope, isn't it? So if we talk about slope, and not only slope, in physics there are many quantities like velocity, acceleration, isn't it, force, where we define these quantities in two ways. The first one is, that is average velocity, average acceleration, and the second is instantaneous velocity, instantaneous acceleration. The word instantaneous carries a very significant meaning here. So similarly, so we will see step by step. Similarly, slope is defined in two ways. That is, the first is average slope and the second is instantaneous slope, isn't it? So what is instantaneous slope? That is when slope is defined at a single point. At a single point, suppose I say that what is slope at point P, any point P, so there is only a single point, so we have to find the tan theta at that point. And whenever we say average slope, average velocity, something like that, then we have two different points separated by finite distance, separated by finite distance. Now what is finite? So in finite means measurable. In physics we deal with basically three quantities. The first is finite, which are measurable, which can be measured and which we use in daily life, isn't it? The second one is infinitesimal, is small, that is it is very small, you can't measure it. And the third one is infinitely large quantities. So all the calculations we deal in for finite or measurable quantity, isn't it? And so these are the slope. Now let us first have a look at average slope. Now what is average slope? So dear students, when we talk about average slope, so let us take first the case of a straight line. So this is a y-axis, x-axis. Consider any straight line, let us suppose I am drawing here, this is a straight line. Now here this is point A, this is point B. The coordinates of A are x1 comma y1, the coordinates of B are x2 comma y2. Now for finding tan theta, what we do, first of all we draw a line parallel to this x-axis. So this is the line parallel to x-axis, and from point B drop a vertical line here, isn't it? So the distance will be like, this is x1. So to locate point A, we must move x1 distance towards x-axis and y1 distance towards y-axis. So this distance is x1, this distance is y1. Similarly, this is x2. It is the x coordinate of point B, and the y coordinate of point B is y2. Are you getting? So here, this is y1, this is y1 here, isn't it? This is y1. So observe carefully, this whole distance is y2, this is y1. So this distance is given by y2 minus y1, is given by y2 minus y1. This is y2 minus y1. And what is y2 minus y1? This is delta y. Similarly, the distance AB, let us suppose this point is C, is given by x2 minus x1, which is given by, that is delta x, and this angle is theta. So what is average slope? So if I wish to find the average slope for the segment, AB, or you can say when you move from point A to B, what is the average slope for that segment? It is given by average slope. So average slope is given by this symbol, is equal to rise by run, as we have learned earlier. And what is rise? When you move from point A to B, what is rise? It means that the shift in vertical direction, So as you move from A to B, you have shifted by amount CB, isn't it? Along vertical direction. And what is run? The shift along horizontal direction. That is, when you move from A to B, you get shifted in x direction by amount delta x. So what is rise? That is delta y, amount of shift along vertical direction. What is run? That is delta x, that is amount of shift along horizontal direction. So this will be given by, that is delta y by delta x. Are you getting? So this is average slope, and this is nothing but tan theta. This is nothing but tan theta. In triangle ABC, tan theta is given by delta y, that is BC by AC. Now, the most important point here is, suppose we have taken any point P and we have to find instantaneous slope at point P, isn't it? So what we do, we draw a line parallel to x-axis here and take this angle. So this angle will also equal to theta, because this is a straight line and these two angles form a pair of corresponding angles. So this will also equal to theta. So here if I write instantaneous slope, at point P, instantaneous slope at point P. So if I write MP, that is instantaneous slope at point P, is also given by tan theta. And this is equal to, this tan theta is also equal to average slope. So the important point, node point we are obtaining here is, for a straight line, what is node point, dear students? That is, what is node point? That is for a straight line, instantaneous slope, that is slope at any point, is equal to average slope. So average slope for a straight line is equal to instantaneous slope at any point on that straight line. Are you getting? This is key point you must remember, isn't it? So this is the logic we are getting from here. Now suppose we have a curve that is non-straight line. There may be many curves. Now we have seen there are curves like this one, inclination, that is slope is increasing, like this one, that is slope is decreasing. So in such cases the slope is not constant, that is the curve is not a straight line. So in such cases, how can we find the instantaneous slope? Let us see. So steps to find instantaneous slope. Now we are step by step approaching towards differentiation. So the step number 1 is choose or select. The step 1, select a straight line segment of the curve. Select a straight line segment of the curve, isn't it? Second, for that straight line segment, find the average slope. So second step is find average slope for that segment, and the final step is instantaneous slope at any point on that straight line segment equals the average slope for that segment. So these are the steps, dear students. So these are very simple steps. Now let us look by having some example. So let us have example of changing slope. So this is y-axis, x-axis. Now here I am drawing a line. Now this is the curve for changing slope. Now let us take two different points here. Let us suppose here this is point P here. We are taking this is point P, isn't it? Now what I am saying that observe the suppose we need to find instantaneous slope at point P. So the very first step what we do, we plot or we draw a line parallel to x-axis here, isn't it? And draw a tangent that passes through this point P and take angle theta. So what is slope at point P? Slope at point P is given by tan theta. This is okay. This is okay. The slope is given by point P, that is theta. Now how can you find tan theta? So let us draw the same figure. I am drawing the same figure. So this is the same figure. Again I am taking a point P here. So this is point P where we need to find the slope. Now dear students, first of all we have marked the angle theta and the slope is given by tan theta. Now the second approach is, if we are able to find the value of theta by taking some protractor or taking this anyhow, if we are able to measure the value of angle theta, then we can directly find the value of instantaneous slope at point P. But suppose if we want to use the formula for tan theta as delta y by delta x, then how can we find or how can we approach to find the instantaneous value? So we are saying that, isn't it? So what we do, observe the point and listen. What was the step number 1? We have to choose the, if we wish to find the instantaneous slope at point P, then we have to choose the straight line segment of this curve. So are you able to observe the straight line segment along this curve? No, this is not a straight line. This is a having curvature. But if I zoom it, now observe this section from here to here. Observe this. Does it appear as a straight line? Definitely yes. Does it appear as a straight line? Yes. If you take these 2 points more close to each other, then it will be appear as a straight line. The more closer you take these 2 points, suppose this is point Q and this is point R. The more closer you take these 2 points to the point P, this segment will approach a straight line. Are you getting? So when you observe the very small segment, of this curve, then this small segment will appear as a straight line. So what is the step number 1? That take 2 points Q and R very close to point P, isn't it? Take 2 points Q and R very close to point P such that take 2 points Q and R very close to point P such that PQR appears as a straight line. So this is the logic. So I am drawing this PQR segment, isn't it? So this PQR segment appears at a straight line. So here in center we have P, this is Q, and this is R. We are zooming it, let us suppose 100 times. So what we get, this is P, this is Q, this is R. Now we have to find tan theta, since we need to find the instantaneous slope at point P. So what we do, I join this, and here this is tan theta. I mean this value is theta, isn't it? So this is theta. Now what happens, since this is a straight line, if this is theta, then this also will be theta, isn't it? So this distance is given by, this is rise represented by delta y, that is change in y coordinate as you move from R to Q, and this distance is given by delta x, that is run, that is change in x coordinates when you move from R to Q. So MP is equal to, that is slope at point P is equal to tan theta, as we have seen here. But how can we find this, the value of tan theta? So this value of tan theta is also given by delta y by delta x. Are you getting? This tan theta is given by, in this triangle, observe triangle RQ, and let us suppose this point is S. Tan theta is given by delta y by delta x. We have to find this theta, but this appears as a straight line. So if this is theta, then this angle also, that is angle QRS, will also equal to theta. And this tan theta can be found out by using the trigonometric ratio tangent formula, that is this tan theta is given by perpendicular by base. So this will be given by delta y by delta x. But what is the condition here, dear students? This delta x is not having finite value, and this delta y is not having finite value. As we have seen earlier, in the case of average slope, that the average slope is given by delta y by delta x, but that delta y and delta x are having finite value, that is measurable value. But here, if you observe, these 2 points are very, very close to the point P. These 2 points are very, very close to point P. So if you find the change in x coordinate, this x coordinate may be having value 0.0001. This y coordinate, change in y coordinate may be having value 0.00002. So this is 1 by 10,000 or 1 by 1,000 something values, which is something value which is very, very close to 0, or you can say approaching to 0. So what we do here, we apply limit delta x tends to 0. So this is the formula, I am writing it. What is instantaneous slope at any point is given by m is equal to limit delta x tends to 0 delta y by delta x, isn't it? So this is how we write. Why do we put the limit delta x tends to 0? Why we are putting here? Because this ratio delta y, because the values delta y and delta x are very, very small, and these values, since this is very small approaching to 0, so that's why these values are known as infinitesimal small. What is delta x? It is having value infinitesimal small. Infinitesimal small. So we write here this delta x approaches to 0, since this is having very small 0.001, 0.00001, isn't it, approaching to 0. And for that infinitesimal value of delta x, we are able to define average slope, isn't it? And this average slope is equal to instantaneous slope. So the conclusion is, the instantaneous slope is also an average slope for infinitesimal small change in x, isn't it? Why we are taking infinitesimal small change? Because if you take 2 different points, suppose this is R and this is S, then this is not a straight line. Are you getting? So when you find the average slope of RS, the average slope for RS will not be equal to the instantaneous slope, because there are many points between R and S which are having different slopes. As we see that here, if you find theta, it will be different. Here it will be different. At point P will be theta will be different. At point S, theta will be different, isn't it? What I am saying, I am drawing it again. Suppose I take 2 points. This is point A and this is point B. So the average slope of point A and point B is given by delta y by delta x, it's okay. But if you take any point in between these 2 points, so the instantaneous slope is changing, as you can observe here. Here theta, 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 theta. So this theta is getting increased. Are you getting? So the slope will also increasing. So in this case, instantaneous slope is not equal to average slope. So to find the average slope at any point P, what we do, actually we have taken a small segment which appears as a straight line. Now if it appears as a straight line, then the average slope for that straight line will get equal to instantaneous slope, or you can say the average slope of this segment is equal to slope at any point between these segments. And since these 2 points are very close to each other, so the value of this delta y here come and the value of this delta x, they are having very small value. So we say that instantaneous value is equal to average value, but the condition is this delta x is very small. So we write here instantaneous slope is average slope, but condition is limit delta x tends to 0. So whenever you have to convert the average value into instantaneous value, take delta x, and or you can say apply the limit delta x tends to 0, isn't it? So this is the very simple method how you find the instantaneous slope, dear friends, isn't it? So let us switch to the next topic, that is physical interpretation of slope, isn't it? So let us suppose have some real life practical examples. For example, if I if I write here, suppose the position of any position position of any particle is given by position of any particle is given by, let us suppose, y is equal to 2t square, where y is position, t is time in seconds, isn't it? So what we say that here, if we change the value of t, suppose t is 0, then y will be 0. Suppose t is 2 second, so 2 square 4, y is having 8 meter. T is 4 square 16 to the 32 meter. T is 636 to the 72 meter. So this y is in meter and this t is in second. So what we see that as time changes, y also, that is position of the particle, changes. So here are the technical terms which you must understand. That is, here t is known as, t is independent quantity. T is independent quantity. Y depends on t, that's why y is known as dependent quantity. Y is known as dependent quantity, or in terms of mathematics we write y is equal to ft, that is read as function in t, function in time. What is position? Function in time. So here y depends on t. So these are the terminologies which we use, isn't it? So what happens if I write, suppose if you observe carefully, when time changes from 2 seconds to 4 seconds, the position of the particle changes from 8 meter to 32 meter, isn't it? So suppose if I write here that for 2-second change in time interval, or you can say for t is equal to 2 second to t is equal to 4 second, change in position, that is delta y, is given by, so at 2 second the position was 8 meter, at 4 second the position was 32 meter. So the change in position is given by 32 meter minus 4 meter, sorry 8 meter, 32 meter minus 8 meter, and this is 24 meter, isn't it? So the what was the time interval for this change happens, that is delta t, time changes, change in time is 2 seconds. So what we write, observe carefully, that change in y, that is change in what is y position for time interval delta t is equal to delta y. It is being represented by delta y. So delta y is change in position corresponding to time interval delta t. Now if I write change in y position for time interval 1 second. So what we do, we divide the expression by delta t. Suppose the change in position corresponding to time interval 2 second is delta y. So change in position corresponding to time interval 1 second is delta y by 2, isn't it? So we divide it by delta y by delta t. And what is this change in position in 1 second? This is, observe carefully, I am writing again, change in position in 1 second delta y by delta t. This can also be written as change in position per unit time is delta y by delta t. Now per unit time, isn't it? So this per unit time can be expressed by the use of single word, that is rate. So rate of change in position, rate of change in position is delta y by delta t. Observe carefully, this is rate of change in position is equal to delta y by delta t. So whenever any quantity is representing delta y by delta x, delta y by delta t, what is it indicating? It is indicating the rate of change with respect to another quantity. So here y is dependent quantity, t is independent quantity, and delta y by delta t is representing the change in y with respect to change in t, or you can say the rate of change of y with respect to t. Now since here we are having two different points, are you getting two different points, 32 meter y2 minus 8 meter, that is y1. So this rate is known as average rate. This rate is known as average rate. This is very important because this delta y by delta t, these are having finite values. As we have seen, we are getting delta y as 24 meter, and if we take delta t as 2 seconds, then delta t also is having finite value. So delta y by delta t will be finite. So this is known as average rate of change, isn't it? So this is average rate. What is the average rate? That is delta y by delta t. Now from this curve, so I am explaining it further, that is y is equal to 2t square. Suppose I am taking t1 is equal to 2 second. So position at this time is given by 8 meter. Suppose I am taking t2 is equal to 5 second. So the position at this point is given by 5 square 25 to the 50 meter. So average rate of change, average rate of change in position, isn't it? So it is given by delta y by delta t, isn't it? That is change in position per unit time. It is known as average rate of change. So delta y is y2 minus y1, that is 50 minus 8, and delta t is given by t2 minus t1, that is 5 minus 2. 50 minus 8 is given by 42, and this is 3. On further solving, you will get that is 14 meter per second. 14 meter per second. Because delta y change in position is in meter and delta t time interval is in second. So this is 14 meter per second. And meter per second, what quantity it is representing? That is velocity. How much distance it is covering per second. It is average rate of change in position, and this is nothing but velocity. So this is average rate of change in position is average velocity, dear students. This is average velocity. So this is the physical interpretation of slope. Now you say that, sir, till now we don't have any idea about the slope. In this slide, what is delta y by delta t, dear students? This delta y by delta t, if you observe carefully, this is representing the average slope of position time curve. This is very important. average slope of position time curve. Are you getting? Just 10 to 15 minutes earlier, we have written that is delta y by delta x, that is average slope. So here we are writing delta y by delta t, it means that average slope of position time curve. And what does this average slope of position time curve? This is nothing but average velocity. Here we have written, and what is this average velocity? Is nothing but this is average rate of change in position. This is average rate of change in position is known as average velocity, and this average velocity is nothing but delta y by delta t, that is average slope. So what information we are getting here, that slope is nothing but rate of change. What is slope? Rate of change. Are you getting? Now we have talked about average slope. Now what is instantaneous rate of change? So since rate of change is given by slope, so if I write instantaneous rate of change, in position, then this will be given by instantaneous slope. And what is instantaneous slope? That is limit delta t tends to 0, delta y by delta t. As we all know that instantaneous slope is also an average slope, but the condition is this denominator, that is delta t, must approach to 0. And very important point, this limit delta y by delta t, this is given by dy by dt. So instead of writing limit delta t tends to 0, we write dy by dt. What does it mean, dy by dt? It means that limit delta t tends to 0, delta y by delta t, isn't it? So this is giving the instantaneous slope, or you can say instantaneous rate of change in position. Are you getting? So this instantaneous rate of change in position becomes equal to average rate of change in position for delta t tends to 0. Now next slide, very important, isn't it? If I write a rate of change, so this rate of change can also be defined in two ways. The first is average rate of change. Let us having function y is equal to fx, or you can say if you are taking earlier example, that is y is function in t, y is representing position and t is time. And the second is instantaneous slope. Instantaneous rate of change. So what is average rate of change? That is delta y by delta t. So this is average rate of change in position. It is given by, it is equal to average velocity of the object. And if we talk about instantaneous rate of change, then this will be limit delta t tends to 0, delta y by delta t is equal to dy by dt. Now let's have some practical idea regarding this. As suppose you are running a vehicle in a highway, so your speedometer shows some reading, isn't it? So if you are accelerating, suppose you are standing by observing a signal, there is a red signal, and as the green signal comes, you accelerate the vehicle, so your speed is getting increased by some rate, isn't it? So your speedometer shows different speeds. Are you getting? So what happens, your speedometer does not show a fixed reading, it is displaying a different readings. So in that case, the instantaneous velocity is not equal to average velocity. Instantaneous velocity is not equal to average velocity. Now the next is, now suppose your speed becomes saturated, it means that you have approached the 80 km/h speed, and now you are going with the same speed along the same direction. So that your speedometer holds the same value, that is 80 km/h, let us say for 10 minutes. For 10 minutes, you are driving a car at the same speed, that is 80 km/h. That is, speedometer shows the same distance, it holds the same value, 80 km/h. It means that within that time interval 10 minutes, the instantaneous speed is 80 km per hour, and that instantaneous speed is equal to average speed. That instantaneous speed is equal to average speed, or you can say that instantaneous velocity is equal to average velocity. But in case of changing speed where you are accelerating, this instantaneous velocity is not equal to average velocity. है ना? So whatever I have just given you the example, I am writing here. And what is that? For uniform velocity, dear students, instantaneous velocity, which is represented by v, is equal to average velocity, represented by v in this way. So for uniform velocity, what happens? This v is equal to average value. These two values are being same for in the case of uniform velocity. That is the average rate of change in position and instantaneous rate of change in position, both are equal. But what happens for non-uniform velocity? For non-uniform velocity, average velocity and instantaneous velocity are different. V is not equal to v. Average velocity is not equal to instantaneous velocity. If you say, let us have some example. Suppose the earlier example we have taken, that is, here it is t and here it is y is equal to 2t square. So t is 0, y is 0, t is 2, y is 8, t is 4, y is 32, t is 6, y is 72. So here now you can observe that the average speed, or you can say average velocity for time 0 to 1 second. So it is given by average velocity, that is average rate of change in position, that is delta y by delta t. So the observe carefully, what is delta y for 0 to 1 second change in position is, so in time, at time t is equal to 0, the position is 0, at time t is equal to 2 seconds, the position is 8 meters. So this is 8 minus 0 by 2 minus 0, that is 4 meter per second. Now average velocity for t is equal to 2 second to t is equal to 4 second. So it is given by again delta y by delta t, that is average rate of change in position. So what is delta y? For 2 to 4 second, the change in position is 32 meter minus 8 meter, and this is 4 second minus 2 second. So this is 24 by 2, that is 12 meter per second. So as you can see, the velocity is getting increased by, because you are accelerating now, So average velocity here, it is different. And if you are accelerating, then if you observe the speedometer, so the value of speedometer is not having the fixed value. It displays different readings because instantaneous velocity of the object are getting increased. So instantaneous velocity is not equal to average velocity in case of non-uniform velocity. What we have written here, I am explaining it here, isn't it? Now what happens? Suppose we have very small time interval. That is, let us suppose this is y is equal to either t, y is equal to 2t square. Now let us suppose when t is equal to 2.1 second, 2.2 second and 2.3 second. So when it is 2.1 second, it will be given by, that is, the value is 8.8 meter, round off to the first decimal place. And if you put 2.2 in the instead of time, you get the value 9.7 meter, rounding off to one decimal place, and here you will get 10.6 meter. Now let us observe the average velocity in this case. Now very important information you are getting, you are going to get here, dear students. Keep patience, very important. The key point, the turning point of this differentiation has arrived. So now if I find the average velocity for time interval 2.1 second to 2.2 second. So it is given by delta y by delta t, And what is the change in position within this time interval is at t point at 2.2 second, it is having position 9.7 meter. At 2.1 second, particle is having position 8.8 meter. So it is given by 9.7 minus 8.8 by time interval is 2.2 second minus 2.1 second. So on solving here, you will get 0.9 by 0.1, and this is equal to 9 meter per second, isn't it? So and second case, average velocity for t is equal to 2.2 second to 2.3 second. Again, this is delta y by delta t. So this will be 10.6 minus 9.7 divided by 2.3 minus 2.2. So it is also equal to 9 meter per second. Now, listen carefully what I am going to say. That within time interval 2.1 second to 2.3 second, the velocity of the object is constant, that is 9 meter per second. It means that for time interval 0.2 seconds, for time interval, very important line, 0.2 seconds, speedometer holds the same value. Speedometer holds the same value, that is 9 meter per second. Now, what is the story? The story goes like, when you accelerate any vehicle, speedometer shows different readings. This is 100% okay. But my dear students, you are able to read those values only because speedometer holds that value for very little time. No matter how little that time is, 0.1 second, 0.2 second, 0.3 second, no matter for how less time the speedometer holds the same value, but you are able to read that value only because it holds the same value for some time. That some time is very less. I agree, I do agree that some time for which the speedometer holds the same value is very less, but it holds the same value for that less time. Maybe it is infinitesimal small, but it is holding the same value for that infinitesimal small time, and only because it holds the same value for infinitesimal small time, you are able to observe that reading. So what is the conclusion we are getting from here is that for that infinitesimal small time interval, for infinitesimal small time interval, the velocity of object, velocity, that is rate of change in position, is almost constant, and this is the case of uniform velocity. And as we know, in the case of uniform velocity, what happens, this instantaneous velocity becomes equal to average velocity. This instantaneous velocity equal to average velocity in case of uniform velocity. So for that small time interval, this instantaneous velocity is equal to average velocity. And what is average velocity? Delta y by delta t. But here this time interval delta t is very small, very small, because only for that small time interval 0.2 second, 0.3 second, speedometer holds the same value, and we can say that instantaneous velocity is equal to average velocity for that small time interval. So here we are writing instantaneous velocity is equal to average rate of change in position, that is average velocity, that is delta y by delta t, but the condition is this delta t must approach to 0. So are you getting now? So what important conclusion we are obtaining from here, that suppose this y is equal to fx. This y is a function in x, isn't it? So its rate of change may be different. But for infinitesimal small change in x, this is very important. For infinitesimal small change in x, rate of change in y is almost constant. This is very important. Rate of change in y is almost constant. And for that infinitesimal small change in x, the instantaneous rate of change is equal to average rate of change because the rate is constant. So this is the important conclusion we are getting. Now there are various applications here. So the very first application we already have seen in the case of, that is in the case of velocity. So I'm again starting from the velocity. So application number 1, since velocity is equal to rate of change in position. So this can be defined in two ways. If I write average velocity, then this will be change in position delta y by delta t, where y is representing the position and t is representing the time. Now, if I wish to find instantaneous velocity, so this instantaneous velocity is given by, so as we all know, this instantaneous value is also equal to average value for very small time interval. So this will be limit delta t tends to 0, delta y by delta t, and this is known as dy by dt, isn't it? So where dy by dt, in terms of maths, this is known as derivative of y with respect to t. And what is y here? Position. So derivative of y with respect to time. Also, what is dy by dt again? This is instantaneous slope of position time curve. Also, this is equal to tan theta, isn't it? Suppose we are having graph like this one. This is time axis, this is position axis, and if I plot a graph like this one, and we have to comment on the velocity of the particle. So what we say here, the slope is increasing. As we have seen, this is the case of increasing slope. Theta increases, so the slope increases. The conclusion goes like this: theta increases, it means that slope increases, isn't it? And what is the slope of position time curve? That is velocity increases. Why? Because velocity is given by dy by dt, isn't it? And this dy by dt is nothing but slope, that is equal to tan theta. So if you are a serious NEET aspirant, then you must be very serious regarding this slope, differentiation, and this all, isn't it? Because the question directly comes from such topics, and this can be the question may be from any chapter, but the concept will be same, that is slope is equal to dy by dx, isn't it? So here, and this process is known as differentiation. What process? That we put here a limit delta t tends to 0, delta y by delta t. I mean, we make delta t very small to have the instantaneous slope. So this process is known as differentiation. What we are getting dy by dt, it is actually the derivative of y with respect to t, isn't it? So let us switch over to the next example. Example number 2, application 2. Suppose we talk about acceleration. So what is acceleration, dear students? Acceleration is equal to rate of change in velocity, that is change in velocity in 1 second. So this is given by, now this again can be defined in two ways. The first is average acceleration. So this is given by delta v by delta t. And the second is instantaneous acceleration, which is simply represented by a. So we have to convert this average into instantaneous. So what we do, we put limit delta t tends to 0, because for that infinitesimal small time interval, that average change is equal to instantaneous change. So this is delta v by delta t, and this is equal to dv by dt, that is known as derivative of velocity with respect to time t, and this is nothing but instantaneous slope of velocity time curve, and this instantaneous slope is given by tan theta, isn't it? So have some examples. Suppose here it is time and here it is velocity, and the curve is like this one. This is parallel to time axis, and you are asked to comment on the acceleration of the particle. So what is how can you find the acceleration is given by slope of vt curve, velocity time curve, and here slope is given by tan theta, and here we can observe this line is parallel to time axis, so theta is equal to 0. Theta is equal to 0. We have seen just 30 minutes before in this lecture, this line is having angle theta 0. Because how can you find angle theta? We construct a line parallel to x-axis and take its inclination. So here theta will be 0. So acceleration is equal to tan 0 is equal to 0. So it is the case of acceleration is 0. It means that change in velocity is 0. So this graph is representing uniform velocity. So this is the beauty of maths and physics. Now you are able to absorb the connection between the two. That's why I have said in the very first lecture that the maths is the language of physics, isn't it? So once you understand the concept of the slope, you find there are many problems in physics very easy and very friendly. You can have some connection between the two. So the next example, next application we have is that is the force. What is the Newton's second law, dear friends, dear students? That force is equal to rate of change of linear momentum. Rate of change in linear momentum. So are you getting now what we do? Now again, this is rate of change. So this force can be defined as 2 ways. Average force, that is delta P by delta T, where P is representing the momentum. So delta P is representing the change in momentum for time interval delta T. So if I wish to find instantaneous force, then what we do? We apply limit here. So limit delta T tends to 0, delta P by delta T, and this is nothing but dP by dt. So this is the, you can say, force is the rate of change of linear momentum. This is Newton's second law. So what is this force? The force is given by slope of PT curve. And what is PT? That is momentum time curve. And again, this is given by tan theta. So these are the various applications. Now we come across many examples when we proceed further in the physics, isn't it? Now, next is, let us have some look at the derivative formulae, which are very important. So the very first formula is d by dx of any constant is equal to 0, because what is dy dx? It is known as differential coefficient. It is representing the rate of change, isn't it? Now if you take derivative of any constant, constant means it is not going to change, so its rate of change is 0, isn't it? So suppose, for example, you come across many situations like d by dx of pi. Pi is a constant, 0. Suppose you are come across d by dx of universal gravitational constant. This is 0, isn't it? So these are the, now the formula is d by dx of trigonometric ratio, that is sin x. So this will be cos x. D by dx of cos x, this will be minus sin x. D by dx of tan x, that is sec square x. D by we will now after that we will have some examples so that the formula will be very clear to you how to use. D by dx of sec x is given by sec x tan x. Now d by dx of of, let us have some exponential function, that is e to the power x is equal to e to the power x, and one very common, this is n x to the power n minus 1. This is the popular viral formula. This is the, you come across these formulas rarely, but this formula, you come across this formula many times. This formula will be going to it, that is d by dx of x to the power n is n x to the power n minus 1. So this is x minus 1. Very important formula, common formula. And d by dx of log x is equal to 1 by x. So these are the some basic formula we have, isn't it? So on basis of this formula, let us have some examples. But before that, Now suppose there are function like c constant, and after that there is a function. So what we do, we take constant outside the differentiation, then we differentiate the function, that is d by dx of fx, isn't it? Now there are some more formula like and before proceeding to that, let us have some examples. For example, if I write y is equal to sine x, so find dy by dx, find dy by dx at x is equal to 30 degree. So dy by dx is equal to d by dx of sine x, that is differentiation, I mean derivative of sine x. So this will be cos x. So we have to find dy by dx at x is equal to 30 degree. So put x is equal to 30 degree. So this is cos 30, and cos 30 is equal to root 3 by 2. So there may be many formula. We will do the formula. For example, if you write d by dx of root x, so this will be actually d by dx of x to the power 1 by 2. And observe the formula d by dx of x to the power n. So this is n x to the power n minus 1. So here in place of n we have 1 by 2. So the formula n comes 1 by 2, then x to the power n minus 1. So n is 1 by 2 minus 1. So this is 1 by 2 x to the power minus 1 by 2. Observe, remember the, remind the lecture 1 of basic maths. So what we do, we shift the x from numerator to denominator, then power will become 1 by 2. And what is 1 by 2? This is nothing but root x. So d by dx of root x is 1 by 2 root x, isn't it? So these are the formula. So let us move to the next, derivative rules. There are some rules. For example, if there are two functions such as u is equal to function in x and v is a different function, it is also in x, that is gx. Suppose u may be sin x cos x and v may be log x tan x, like that. And if I wish to find, and suppose y is equal to u into v, so dy by dx, this is known as product rule, dy by dx is equal to dy by dx of u into v. So what we do here, the formula goes like u dv by dx plus v du by dx. So let us understand by having example. Suppose u is equal to sin x and v is equal to log x. So what we do, we have to find d by dx of sin x into log x. Formula is u dv by dx. U is sin x, so d by dx of log x plus log x d by dx of sin x. So this is the formula. So here we get sin x, log x differentiation is 1 by x plus log x, and d by dx of sin x is cos x. So this is the answer, isn't it? Second formula, let us suppose d by dx of u plus minus v is equal to d by dx of u plus minus d by dx of v. Very important. Suppose you have to find d by dx of x square plus 3x plus 4. So separate it. D by dx of x square plus d by dx of 3x plus d by dx of 4. So d by dx of x square is 2x, x to the power n minus 1 wala formula. And this is, take 3 outside because d by dx of c into any function, take constant outside the differentiation, you are left with d by dx of x plus constant differentiation is 0. So this will be 2x plus 3, d by dx of x is 1. So the answer is 2x plus 3. Third formula is d by dx of u by v, quotient rule. So this is v du by dx, v du by dx minus u dv by dx, and whole divided by v square. So this formula is rarely used. but you must know this formula. So there can be examples. For example, d by dx of let us suppose sine x by x. So what we do, we du by dx, differentiating the sine x, we have cos x minus u, that is sine x, differentiating the denominator is 1 whole divided by x square. So this is the answer, that is x cos x minus sine x divided by x square. Now next is chain rule. Here very important, dear students. Suppose y is a function in x and x is a function in t, isn't it? I'm giving the example. Suppose y is equal to sine x and x is equal to t square, and you have to find dy by dt. We have to find dy by dt. I'm saying you to observe one thing, that whatever examples we have taken here, so the function is in x and we are differentiating it with respect to x. In any example you say, you observe, here the functions are in x and we are differentiating it with respect to x, because d by dx is, we are different, that is differential coefficient, and we are differentiating it with respect to x. In earlier examples as well, you observe that here function is in x, that is y is equal to root x, and we are differentiating it with respect to x, that is d by dx. But there are some cases, and you come across many situations in physics numericals, where the function is in different variable and you have to differentiate it with respect to different variable. For example, what I am saying here is very simple, that if I wish to find dy by dt, it means that this is d by dt of sine x. Y is sine x, no? Y is nothing but sine x. Now observe carefully. Till now, what we have done, the function is in x and we have been differentiating that function with respect to x. But here the two things are different. The function is in x and we are differentiating this function with respect to t and not with respect to x. So in such cases, we have to use chain rule, and this rule says that this dy by dt can be written as dy by dx multiplied by dx by dt. So divide and multiplied by dx and rearrange it. So the first term becomes dy by dx and the second term becomes dx by dt. So again, this formula can be written as, this is a dy by dx of dy by dx. So dy by dx of y. What is y? That is sine x. And after that, dx by dt. After that is d by dt of x. And what is x here? Here x is t square. So this is t. Solve it. So this is the formula, basic formula. So what is d by dx of sine x? This is cos x. And what is d by dt of t square? That is 2t. And you can write x is equal to t square. So the answer will be 2t into cos of t square. So this is how we solve it. So instead of learning this formula, instead of rote and learning, let us understand the same formula. I am giving you the trick here. Since y is equal to sine of t square. Sine x means sine of t here. So sine of t square. So in such cases, what you do, first of all, observe, there is one function that is t square. This is a function in t, and of that function we have another function sine. So here it is like function of function, isn't it? Here it is like function of function. This is sine function of the function t square. So in such cases, what we do, if we wish to find dy by dt, so when you move from left to right, the first function you come across is sine function. So it is very simple. If you differentiate the sine, if you differentiate sine of anything, and if you differentiate it, you will get cos of that thing. This anything may be anything, but if you differentiate sine, you will have cos of that thing. So here sine of t square, if I differentiate this sine, we will have cos of t square. So the first function we have differentiated. Now the second function we come across t square. The differentiation of t square is 2t. This is solved. isn't it? So the formula is 2t cos of t square. Now there are many examples. Suppose I am taking another examples. If I write d by dx of log of sin x. Now observe carefully. This is again the first function is sine, and this sin x we are taking log of sin x. It is again the case of function of function. So when you move from left to right, you come across the very first function is log of sin x. So log of anything, if you differentiate it, you will get 1 by that thing. Log of anything, you will, if you differentiate it, you will get 1 divided by that thing. So here we are having log of sin x. So you will get 1 by sin x. And after that, sin x is also a function. So differentiate sin x, that is cos x. And this will be cos x by sin x, that is cot x. This is very simple, dear students. Now the next is, now I am changing the pattern. Suppose if I write d by dx of sin z, and the value of z is missing. Z is a function. Z is again a function, but here it is missing. Now, as I have said earlier that here the function is in z, but we are different. We have to differentiate it with respect to x. So what we do, we differentiated sine function. So what is the differentiation of sine? That is cos of z, and after that we put dz by dx. Whatever here, suppose here it was sine x. So we are differentiating this d by dx of sine x. We are getting cos x. So after differentiating sine, we are getting cos. Then we have differentiated this t square, that is d by dt of t square. We have got 2t. Similarly, whatever the function this z carries, after that you have to differentiate it with respect to z. For example, this is d by dy of x square. Observe, the function is in x, but we have to differentiate it with respect to y. So what we do, apply the formula x to the power n. So this will be 2x. And after that, differentiate this x with respect to y. Are you getting? Suppose if I write d by dt of e to the power x. The function is e to the power x. So its differentiation will remain as it is. So write one more formula, that d by dx of e to the power x is equal to e to the power x, exponential x. So what is d by dt of e to the power x? So first we have to differentiate e to the power x, Then this function is in x and we have to differentiate it with respect to t. So put here dx by dt. So this is the very fundamental logic, isn't it? Now next is double differentiation. So dear students, suppose I am writing y is equal to 2t squared. Suppose this is representing the position. So what is velocity here? So velocity is rate of change of position, that is dy by dt. So it is given by d by dt of 2t square. So this will be 2 d by dt of t square. So t square differentiation is 2t. This is given by 4t. So velocity is equal to 4t. Now if I wish to find acceleration, so the acceleration is dv by dt. So this will be d by dt of 4t and this will be 4, isn't it? So acceleration is constant, that is 4, independent of time, that is no term of t comes here. So what happens, this acceleration can be written as dv by dt and this v can be written as dy by dt. So you are differentiating position with respect to time, you are getting velocity. Then you are again differentiating whatever you are getting from the first differentiation, you are again differentiating it with respect to time, you get acceleration. So we will write acceleration is equal to d square y by dt square. It means that you are differentiating 2 times the position. In the first differentiation, you get the velocity, and then if you again differentiate it with respect to time, you get acceleration. So acceleration can be represented as d square y by dt square. That is the way of representation of double differentiation. It means that you are differentiating the position 2 times. So this is double differentiation. It has got used in finding the maxima and minima. So here we come across the last topic of this chapter, differentiation. Now observe carefully, dear students. Suppose if I have there, now what is the use of maxima and minima? Listen, there are many situations you come across physics numericals, and there are many function which has got some maximum value, and after that its value is decreasing, and after that it has got some minimum value. So this is the beauty of differentiation, that without plotting the curve, we are able to find those maximum and minimum values, isn't it? So let us suppose I am taking an example. Suppose there is a function whose curve is like this one. There is a function like this, isn't it? So as we can see that the function is having the function is having the maximum value at this point and minimum value at this point, isn't it? Now what happens, uh, we can say that before this point the slope is, as you see, the slope is decreasing and finally it decreases to 0, and here the slope is increasing. At this point the slope is having value 0. So how can you find slope at this point, that is the maximum minimum point? So what is the procedure to find slope? So first we have to draw tangent here. First we have to draw tangent. So if I draw tangent here, so this is like this, and if I draw tangent here, this is like this. So as we have learned in just 20 to 30 minutes before, that this line is parallel to the x-axis, so its slope, the slope of these two lines, is equal to 0. This is very important information. What is that information? That whenever the curve reaches its maximum value and minimum value, the slope of the curve becomes 0. The slope of the curve becomes 0. This is the logic of finding maximum and minimum value of any function. So what is the step number 1? Whenever the function achieves its maximum value, the slope is 0. Now how can we find out of these two values, when we have the maximum and when we have the minimum values? Because at these 2 points, in both the points the slope is 0. So what we do, we take two different points just before this points. Let us suppose this point is P and this point is Q. So we take 2 points just before this. That is, suppose here we are taking point A. Suppose here we are taking point A and here we are taking point B. Here we are taking point R. Here we are taking point R and here we are taking point S, isn't it? Now let us draw tangent to find the slope here. So the tangent goes like, by touching the curve at single point. So this is the tangent. Isn't it? And here we have the tangent. Like this one. So how can we take the angle theta? We we construct a line parallel to x-axis and then we take angle theta. So here it is the tangent to point P. Actually it is parallel to x-axis, isn't it? So at the point of maxima and minima, the tangent becomes parallel to x-axis. So at this point the slope is 0, because tangent of theta is the slope and theta is 0 means slope is 0. And before this point, suppose we are taking point A and this is point B. So at point B, let us suppose this angle is 45 degree and this angle is also, let us suppose, 45 degree. So again here, if I plot a point, let us suppose this angle is 45 degree, and here if I plot a tangent, so this angle is 45 degree. So here the slope at point A, no, the slope at point A is, so observe carefully here, it is the, this point, this is the tangent to this point, and this is the straight line. So this tangent is having value 45 degree. I mean, this inclination of this line from this x-axis line parallel to x-axis is 45 degree. So slope at A is tan 45, because angle is 45 degree is equal to 1. This angle is 45 degree, and this we are taking it as anti-clockwise direction. So this is slope is equal to 1. And the slope at point B is, observe carefully dear students, and remember the second lecture, here it is the line and here it is the tangent at point B. So this angle, we take the tangent of this angle, है ना? But this angle we are taking it as clockwise, because this is the reference line. This black line is parallel to x-axis, and this is the tangent. We have to take the angle of this tangent from this reference line. So from this reference line, we are moving towards clockwise, and clockwise sense is, according to sign convention, taken as minus 45. So this value is minus of 1, isn't it? So what is MB minus MA? What is MB minus MA? This is minus 1 is equal to minus 2, isn't it? So this is nothing but change in slope. So if I wish to find d square y by dx square at point P, so its value is given by dy dx of dy by dx. Just we have learned double differentiation. And what is dy by dx? This dy by dx is nothing but slope. This dy by dx is nothing but slope. So this is d by dx of slope. Are you getting? D by dx of slope. So what is d by dx of slope? This is rate of change of slope. This is rate of change of slope. And since this is rate of change of slope, that is mb minus ma by xb minus xa. So xb matlab, xb means x coordinate of point B, and xa means x coordinate of point A. So this denominator is positive, but numerator it is negative. This is delta x. So this value is negative. This is important. And this is for point P. Similarly, if you find for point Q, the same procedure you follow, then this d square y by dx square will come positive. Are you getting? So what are the steps to finding maximum and minima? Steps. So steps are like follows. Step number 1, put dy by dx is equal to 0 and find the value of x and find the values of x. Now the second step, if d square y by dx square for the values of x found in step 1 is 1 positive, then x corresponds to minimum, that is minimum value of function. And if it is negative, then x corresponds to maxima. Isn't it? So these are the rules, steps you have to keep in mind. So the next is, now let us have some practical examples here. So question number 1, velocity of a particle is given by v is equal to 60 square minus 60 cube. At what values of t will the velocity will be maximum and minimum? So dear students, this is again velocity is function in t here, and we are asked to find the maximum velocity, that is the maximum value of this function and minimum value of this function. So this is the concept of maxima and minima. So what we do, first write the expression v is equal to 60 square minus 60 cube. Now for maxima or minima, the very first step, that is step number 1, put dv by dt is equal to 0. So dv by dt is equal to 0 implies that d by dt of 60 square 60 square minus 60 cube is equal to 0, implies that d by dt of, separate these terms, 60 square minus d by dt of 60 cube is equal to 0. 6, take it outside the integration, and differentiation of t2 square is 2t, so this will be 12t, minus, take 3 outside the differentiation, integration of 3t is 3t square, that will be 18t square is equal to 0. Now what we get? We get 12t to take common as 60, so this will be 2 minus 3t is equal to 0, isn't it? So we will have two values, either 60 may be equal to 0, implies that t is equal to 0, the first value of time, and second is, or 2 minus 3t is equal to 0, implies that t is equal to 2 by 3 seconds. So this is the second value. So these are the two values for which the slope of this VT curve will be 0. It means that these two values correspond to the maximum and minimum value. So out of these two values, we have to choose which one corresponds to maximum and which one corresponds to minimum. So what we do, now we find step number 2. Step number 2. So d square v by dt square, d square y by dx square we have to find. So here in term of y, instead of y we have v, and instead of x we have t. So this will be d by dt of velocity, d by dt of dv by dt, and we have dv by dt as, we have found a dv by dt. So what is dv by dt? So this is dv by dt, we are differentiating it. So 12t minus 18t square, 12t minus 18t square. So d square v by dt square is equal to d square v by dt square is equal to d by dt of 12t minus 18t square. So this will be 12 minus 36t. Now we have to check the value of d square v by dt square for t is equal to 0. So this will be 12 minus 36 into 0. So this is 12. So this value is positive, and therefore t is equal to 0 corresponds to minimum value of velocity, isn't it? So at t is equal to 0, velocity is minimum. So first answer we have find, and let us check for the second one as well. So d square by dt square at t is equal to 2 by 3 now. The second value of t is 2 by 3. 2 by 3. So this will be 12t, that is 2 by 3 minus 36. No. 12 minus 36t. This is 12 minus 36, 2 by 3. So this will be 12 minus 3, 12, 24 is equal to minus 12, that is having negative value. So what happens? D square v by dt square is negative. So t is equal to 2 by 3 corresponds to v maximum. So we have found the value that at t is equal to 0, at what values of t is equal to 0 and t is equal to 2 by 3, v velocity will be maximum and minimum. Now if the question further asks that find the maximum and minimum value of velocity, then what will you do? You put the value of t, that is 0 and 2 by 3 in the given expression of velocity. From here you get the minimum velocity and maximum velocity. Now next question, d by dx of sine square root x. Now observe, dear students, first of all you have to understand what is sine square x. So this is nothing but sine x whole square. So this is how we write sine x whole square, sine square x. So this question is d by dx of sine square root x. It means that this is d by dx of sine of root x square. Now as you can see, this is the case of function of function of function. How many functions are you able to see here? First of all, there is bracket function, square function. Second is sine function, and the third one is root function. So step by step we are solving. So d by dx of x square is 2x. It means that d by dx of whatever in this box is square, it will be 2 into that box, for example. Now d by dx of, if you differentiate Sine of box, this will be cos of box. Box may have anything, don't bother about that, but sine gets converted into cos if you differentiate it. Then the third is d by dx of root over x. This we have found it, that is 1 by 2 root x by using the same formula x to the power n, isn't it? So this will be d by dx of root anything in box. This will be 1 by root anything in box, isn't it? Now, step by step, the very first function here you are getting is this bracket square. So this will be 2 into this bracket, whatever will be in this box. So this is sine root x. So square function is differentiated. Now you come across second function is sine. So sine of root x. So sine gets converted into cos. So this will be cos of root x. Then root x. This will be 1 by 2 root x. So this is the formula. This 2 gets cancelled. And you will get sine root x. And this will be cos root x whole divided by root x. So in maths, we generally don't put root in the denominator. So we multiply it root x in the denominator as well, numerator. But in terms of physics, this may be the answer, isn't it? So this is solved. Next, a metallic disc is being heated. Its area in meter square is given by A is equal to 5t square plus 4t plus 8. Where t is in time in seconds, calculate the ratio of increase in area at t is equal to 3 seconds. Rate of increase in area, it means that rate of change in area, it means that we have to find rate is nothing but dA by dt at which time t is equal to 3 seconds. This we need to find. So first of all, we will find dA by dt, that differentiate the given expression of A. And what is A? That is 5t square plus 4t plus 8. 5t square plus 4t plus 8. So this will be dA by dt. So 5t square, separate the terms. So this will be d by dt of so this will be 10t plus 4. Now at t is equal to 3 seconds, at t is equal to 3 seconds, that is dA by dt at t is equal to 3 seconds is equal to substitute the value of t is equal to 3 in this expression. You will get 10 3 plus 4, that is 34 meter square per second, because it is rate of increase of area. So this is the answer, dear students. Now next, an equation of SHM, that is simple harmonic motion, the second last chapter of class 11, is given by y is equal to a sine, actually this is omega t, this is a sine omega t, isn't it? So I am writing here y is equal to a sine omega t. Your omega is the angular frequency, t is the time. Find velocity, acceleration and force at time t is equal to 2 pi by omega and t is equal to pi by omega. So since velocity of SHM is given by, again this is dy by dt, that is d by dt of a sine omega t. Here a is the amplitude, that is constant for given SHM. So take it outside, so you are left with d by dt of sine omega t. So here it is, the first function is sine, so the differentiation of sine is cos omega t, and the second function is omega, so differentiate it is omega. So v is equal to omega a cos omega t. So here we got the expression for v, isn't it? Now find the expression for a. What is acceleration? So acceleration is given by dv by dt. So acceleration is d by dt of this v, that is omega a cos omega t, omega a cos omega t. Now for given SHM, amplitude and angular frequency, that is omega are constant, so take them outside. So d by dt of cos omega t. So differentiation of cos is sine, actually minus sine omega t, and omega t, differentiation of omega t is omega. So acceleration is equal to minus omega square a sine omega t. And what is this sine omega t, dear students? This is nothing but y, which is given in the expression. So this is minus omega square y. And the third one you have to find is force. So force is given by mass into acceleration. So this is nothing but minus m omega square y. So this is the expression for force. Now we have to find this value at t is equal to 2 pi by omega. So the first is at t is equal to 2 pi by omega. So what is v? Substitute the value of t is equal to 2 pi by omega in this expression. What we have found, this is omega a and cos, this is omega, and in place of t write 2 pi by omega. So omega omega gets cancelled, this is cos 2 pi. So v is equal to cos 2 pi. 2 pi means 360 degree, that is cos 0, that is equal to 1. So v is equal to omega a. This we have found. Now acceleration at t is equal to 2 pi by omega. This is minus omega square. This is a sine. This is omega is 2 pi by t omega, and t is equal to 2 pi by omega. Omega omega gets cancelled. 2 pi 360 sine 0 0, that is acceleration is equal to 0 and implies that force is equal to 0. In this way, by substituting the value of t as pi by omega, you can find the second part as well, isn't it? So find it and write in the comment box. Now d by dx of log of sine 2x. The first function you come across is log. So log of, when you differentiate log, the function goes into the denominator. So d by dx of log sine 2x. So log of anything, if you observe d by dx of log on anything, this will be log of box is equal to 1 by box, isn't it? Box may have anything. So this will be 1 by sine 2x, 1 by sine 2x. Then second function you come across is sine of 2x, that will be cos of 2x, and the third function is 2x, that is 2. So this will be 2 of cos 2x by sine 2x. So this will be 2 of cot 2x. So this is the differentiation of this one, isn't it? Next is internal energy of 1 mole of an ideal gas. So internal energy is given by U is equal to 5RT. Find molar specific heat at constant volume. So molar specific heat is given by, dear student, that is du by dt, isn't it? 1 by n du by dt, but here 1 mole is given, so n is equal to 1. So this will be d by dt of, here T is temperature, no? So we have to differentiate this internal energy with respect to temperature, 5RT. So 5R, R is the universal gas constant, take it outside, so this will be 5R, and this will be d by dt of T, this is equal to 1, so CV is equal to 5R, isn't it? Now next, CV is equal to 5R. Next, magnetic flux linked with a coil having a resistance 4 ohm is given by, so 5, this is find magnitude of induced EMF and induced current at t is equal to 4 seconds. So dear students, as per Faraday's law, we have the formula for that is induced EMF is n d phi by dt, but here it is a coil with is having single turn. So the formula for n is actually d phi by dt, n d phi by dt, but here n is 1 because coil is having single turn. So here we have the formula d phi by dt. So this is d by dt of phi, that is equal to 5t square minus 2t plus 3. On solving, you will get 10t minus 2. So at t is equal to 4 second, at t is equal to 4 second, the magnitude of induced EMF is given by, so this is the expression for E, that is EMF, which depends on time t. So at t is equal to 1 second, if you wish to find, then put t is equal to 1 here. Here we are asked to find EMF at t is equal to 4 second. So put the value of t as 4. So this will be 10 into 4 minus 2, that is equal to 38 volt. Because it is, we are finding EMF, so this will be expressed as volt. And what is current? Induced current is given by E by R, that is voltage by resistance, isn't it? Ohm's law. So this will be 38 by resistance is given by 4 ohm. Question given. So this will be 4 9s are 36.5 ampere induced current. So these are the various places where we have found there is a direct relation between, differentiation, slope, and all these things. So that's all for dear students. That's all for this lecture, isn't it? So that's all for this lecture. Thank you. Thanks. And in the upcoming lecture, that is in lecture number 5, we will deal with integration, and integration plays a crucial role, very important role in physics. The students who find difficulties in slope differentiation and integration actually will have a fear of physics, because in physics there are 60, 70, 80% chapters where this differentiation and integration play a very crucial role. So if you skip these, then that 80% chapter will be skipped and you will get nothing from physics, isn't it? So keep patience, just go through the lectures, and anywhere if you find difficulty, then don't hesitate, just comment in the comment box. I will make a separate video, separate questions I will take, and make a separate lecture on that particular doubt, isn't it? So that's all for this lecture. Thank you, all the best.